Hello students, I hope you all are fine. So students, we have done method of preparation of aldehyde and ketone. Today we will do some questions related to preparation method of the aldehyde and ketone. Students, see the question number first. Our question number first is, which of the following method cannot produce aldehyde? Okay, so some methods are given that which one of following cannot produce aldehyde. We will see that. So here option A is oxidation of primary alcohol. Yes, oxidation of primary alcohol we know very well because we have discussed all the reactions. So by oxidation of the primary alcohol we get aldehyde. We get aldehyde. When we do reaction in presence of the chromium trioxide, in presence of the PCC, pyrimidine chlorochromate, again, then we get from oxidation of primary alcohol, we get aldehyde. So this is the method for preparation of aldehyde. Then, but he is asking about cannot. Then second, dehydrogenation of secondary alcohol. Yes, this is not used for the preparation of the alcohol because secondary alcohol, oxidation of secondary alcohol, or we can say dehydrogenation. Because dehydrogenation means removal of hydrogen, and dehydrogenation means removal of hydrogen. So oxidation of secondary alcohol, it gives us ketone. It do not give us aldehyde. So students, dehydrogenation of secondary alcohol, this method is used for preparation of the ketone only. This is not used for preparation of the aldehyde. So here option B will be the right. Now see the next option also, ozonolysis of alkene. By ozonolysis of alkene we can prepare both aldehyde as well as ketone. Okay, so we can prepare aldehyde from this one. Then hydration of ethine with acid. From this hydration of ethine we can also get the aldehyde as well as we can get the ketone also. But student, from dehydrogenation of secondary alcohol we get only ketone. Do not we produce aldehyde. So here option B will be the right option for this question. Our next question is question number 2. Which of the following reaction can produce ketones? Okay, now we will see by which reaction we can produce the ketone. Here option A is oxidation of primary alcohol. No, from oxidation of primary alcohol we can get aldehyde. In first question we have discussed now. Okay, dehydrogenation of the primary alcohol. Dehydrogenation means removal of hydrogen. Further removal of hydrogen means oxidation. Okay, so further from primary alcohol dehydrogenation we can get only aldehyde, not ketone. Dehydrogenation of tertiary alcohol. Tertiary alcohol cannot show the dehydrogenation reaction in simple conditions, but in drastic condition it can dehydrogenation, but not dehydrogenation take place. There dehydration of alcohol take place and formation of alkene will take place here. Again, then students, oxidation of secondary alcohol. I have already told in first question, I have already explained that from oxidation of secondary alcohol we get ketone. So he is asking that by which reaction we can produce ketone. So we can produce ketone by oxidation of the secondary alcohol. So here option D is the right option for this question. Students, now see the next question. Our next question is conversion of propane, okay, to acetone require three important reagents. Identify which of the following is not of the three. Conversion of the propane. We have propane. This is propane. We want to convert it into the acetone. We want to convert it into the acetone. Okay. So how can we convert? Students, we have already discussed one method of preparation of the aldehyde and ketone by hydration of the alkyne. By hydration of alkyne. Hydration of alkyne means we do hydration. Hydration means addition of water. And student, here we will take the presence of the sulfuric acid. Here we will take presence of sulfuric acid as well as Hg2 positive, or we can say HgSO4 we will take. So these reagent we will take for this reaction. Now see the options. Water. Yes, we take water in hydration of alkyne. Zinc dust. No, we do not take zinc dust. H2SO4. Yes, we take this one also. HgSO4. Yes, we take this one also. But here zinc dust we do not take for this reaction. Okay. So here he is asking which one of following is not one of the three is the reagent. So here zinc is not the reagent. So students, here right option will be the B. Right option will be B. Okay. Now students, let's see the next question. Our next question is, what is the catalyst used in hydrogenation of acetyl chloride to produce ethanol? Okay, we have acetyl chloride. And we want to produce ethanol. Which catalyst we can use? Options are platinum over BaSO4, platinum over copper sulfate, palladium over barium sulfate, palladium over copper sulfate. Students, we have done one reaction that is used only for preparation of the aldehyde, that is known as the Rosenmund reaction. In Rosenmund reaction, acyl chloride means RCOCl, acyl chloride in presence of we will do the hydrogenation in presence of palladium over barium sulfate. Then they will give us aldehyde. Okay, so which catalyst we will use? PDBaSO4. So here option C. This catalyst is also known as the Lindlar catalyst. So students, here we will use the catalyst palladium over the barium sulfate, and this reaction is known as the Rosenmund reaction, and name of this catalyst is Lindlar catalyst. I hope this question is clear to you. Now let's move to the next question. Our question number 5. Which of the following carbonyl compound can be prepared from Rosenmund reaction? So we have discussed just now Rosenmund reaction. From Rosenmund reaction, in we do the hydrogenation in presence of the palladium and barium sulfate, means in presence of the Lindlar catalyst, and we get aldehyde only. We get aldehyde only, and especially we get benzaldehyde. Okay, students, then we will see. Methanol, no, we cannot get the methanol from this. Acetone we cannot get, because this method, Rosenmund reaction, is used only for the preparation of the aldehyde. Butanone, no, we cannot produce ketone by Rosenmund. Benzaldehyde, yes, we can get the benzaldehyde. If we have acyl chloride, means benzoyl chloride if we have, so we do hydrogenation in presence of palladium over barium sulfate, then we get benzaldehyde. Then we get benzaldehyde. So students, we can get the benzaldehyde by Rosenmund reaction. So here option D will be the correct option for this question. Okay, I hope this question is also clear to you. Now let's see the next question, our question number 6. What is the question? Which of the following is required in Stephen reaction? Students, what do you mean by the Stephen reaction? In Stephen reaction, we use nitriles. We use nitriles for formation of the aldehyde. For formation of the aldehydes. Okay, how can we prepare? Students, here we use the SnCl2, stannous chloride plus hydrochloric acid. Then reduction will take place here. First of all, formation of imine will take place. From here, one bond will break and one hydrogen goes to this one hydrogen goes to this one. Means first formation of imine take place. After that, it is followed by the hydrolysis. Then what will happen, students? Oxygen will goes to this one and 2 hydrogen will goes to this one. So finally we get the aldehyde plus ammonia. So in Stephen reaction, we use the SnCl2 and HCl, and from nitrile we can get the aldehyde. So now see the option, in which option this reagent is given to us. LiCl, no, we do not use the lithium chloride. NiCl2, we will not use. SnCl2, yes, we use the SnCl2 for this reaction, for Stephen reaction. It is also known as the Stephen reduction, because here we are adding the hydrogen, and addition of hydrogen is known as the reduction. Okay, students, so here we will take the SnCl2. Now our next question is, which of the following compound help in reducing ester to the aldehyde? Which can reduce ester to aldehyde? Okay, we have already discussed this reaction in method of preparation for reduction of ester into aldehyde. We use binyl H, no, binyl H is not the word. Dibyl H, yes, we use the dibyl H. Dibyl H is a selective reagent. Selective, because it shows the selective reduction. It can reduce only ester and nitriles, okay, into the aldehyde. Student, dibyl H is diisobutyl aluminium hydride. Diisobutyl aluminium hydride. This is dibyl H. and it is the selective reagent. It is used for reducing ester and reducing nitrile into the aldehyde. Now students, next question, identify X in the reaction given below. Okay, this reaction is given to us. Here we have toluene, methyl benzene we have. Okay, this is X. Solvent is carbon disulfide, and in second step it is followed by the hydrolysis. Then it give us benzaldehyde. Okay students, this is the Itard reaction. Because Itard reaction is that in which we can prepare benzaldehyde from toluene. Here we will use the reagent chromyl chloride, and here we will use the anhydrous solvent. We can take carbon disulfide or CCl4, carbon tetrachloride also, and it is followed by the hydrolysis. Okay students, so here see, X will be CrO2Cl2. It is given in any option? CrO3 no, CrO2Cl2 yes. Here X is chromyl chloride, CrO2Cl2. Question number 9 is, benzaldehyde can be obtained from hydrolysis of the product formed during side chain chlorination of the toluene. Yes. Side chain chlorination of the toluene. If you have toluene, this is toluene. Okay. If we do chlorination in presence of the sunlight, then side chain chlorination will take place and it will produce benzyl chloride. Then hydrolysis of this product we will do hydrolysis of this one, and finally what we can get benzaldehyde. Okay students, so this is the right statement, we can produce, so it is true. Our last question of today, question number 10. Identify the reagent for conversion of chlorobenzene. Students, we have chlorobenzene. Convert it into the 3-chlorobenzaldehyde. 3-chlorobenzaldehyde means direct we are attaching this group to the benzaldehyde. Students, you have seen the Gattermann-Koch reaction for this. When benzene is treated with carbon monoxide plus HCl, okay, in presence of anhydrous AlCl3, or we can take also cuprous chloride, CuCl. We can also take the cuprous chloride, CuCl. Then we get benzaldehyde. We get benzaldehyde. So this one is Gattermann-Koch reaction. Gattermann-Koch reaction. So student, by which reagent we can do this reaction? These. So see, do we have these reagent in any option? CrO3 no, CrO2Cl2 no, they show the Itard reaction. This also not. CO plus HCl and CuCl we can take. So option D will be the right option for this question. So student, I hope all questions are clear to you. So thank you. Have a nice day.